Hello viewers, in today's session we are going to discuss the solution of this equation containing a modulus function. So here we have to solve the equation mod of x minus 1 minus mod of x minus 2 is equal to 1, and here in this class we'll show that this equation has infinite solutions, right? So before finding out the solution of this equation, let us quickly see the definition of mod function, and let us define mod of x minus 1 and mod of x minus 2. So now mod of m is defined as the positive m when m is greater than or equal to 0, and mod of m is equal to negative m when m is less than 0. So using this definition, let us define a mod of x minus 1. So mod of x minus 1 is positive x minus 1 whenever x minus 1 is greater than or equal to 0, and from this inequality we can write x is greater than or equal to 1, and mod of x minus 1 is negative of x minus 1, that is minus x plus 1 when x minus 1 is less than 0, and x minus 1 less than 0 implies x is less than 1. And similarly we can define mod of x minus 2, and mod of x minus 2 is positive x minus 2 when x minus 2 is greater than or equal to 0. So this implies x is greater than or equal to 2, and mod of x minus 2 is negative of x minus 2, that is minus x plus 2 when x minus 2 is less than 0, and this inequality implies that x is less than 2, right? So this is how we can define mod of x minus 1 and mod of x minus 2. Now let us find out the critical points. So the critical points can be obtained by equating this expression which is inside the mod function symbol equal to 0 and solving the equation. So here we have x minus 1 inside the mod function symbol. So the first critical point is obtained by equating x minus 1 is equal to 0, and the second critical point can be obtained by equating x minus 2 is equal to 0. So from here we have x is equal to 1, and from here we have x is equal to 2. So here we have two critical points, 1 and 2, and let us represent these two critical points on the real number line. So now here we have the real number line minus infinity to positive infinity, and here we have x is equal to 1, and here we have x is equal to 2. Now these two critical points divide this real number line into three sub intervals. That is, one is from x greater than minus infinity to 1, then we have x greater than or equal to 1, less than or equal to 2, and the third interval is x greater than 2 and less than infinity, right? So let us now consider these three intervals one by one. So first we'll consider this one. So here we have x greater than minus infinity less than 1. We can also write it as simply x less than 1, or we can write x belonging to minus infinity to 1, right? So when x belongs to minus infinity to 1, or x is less than 1, then let us define mod of x minus 1 and mod of x minus 2. So mod of x minus 1 is equal to negative of x plus 1, that is negative of x minus 1 when x is less than 1. So here we have mod of x minus 1 is equal to minus x plus 1, and mod of x minus 2 is equal to negative of x minus 2, that is negative of x plus 2 when x is less than 2, and here we have x less than 1. So we have here minus x plus 2. So now we can write this equation as minus x plus 1, then we have minus, and then we have minus x plus 2 equal to 1. So we can now simplify it. Minus x plus 1, here we have plus x, and here we have minus 2, and here we have 1. So here the right hand side of this equation is equal to 1, right? So now minus x and x get cancelled, so we have 1 minus 2, that is equal to minus 1, and this is equal to 1, which is a false statement, right? So when we take this interval x less than 1, then we arrive at this statement, that is minus 1 is equal to 1, which is a false statement because minus 1 is not equal to 1. So the solution of this equation does not exist in this interval when x is less than 1. So now let us consider the second interval. So now let us consider x greater than or equal to 1, less than or equal to 2, or we can write x belonging to the interval 1 to 2. And now let us define mod of x minus 1 and mod of x minus 2 in this interval. So here we have x is greater than or equal to 1, and here we have x greater than or equal to 1. So mod of x minus 1 is simply positive x minus 1, that is simply x minus 1. And here we have mod of x minus 2. Mod of x minus 2 is equal to negative of x plus 2 when x is less than 2. So here we have x is less than 2. So we can now write here negative of x plus 2. So now replacing mod of x minus 1 by x minus 1 and mod of x minus 2 by minus x plus 2 in this equation, we can now write x minus 1 minus, and we have minus x plus 2, and here we have 1. So we can now simplify it. This is positive x, then we have minus 2 is equal to 1. So x plus x is 2x, and minus 1 minus 2 is minus 3, and here we have 1. So we can now easily solve this linear equation in one variable. So we have 2x is equal to 1 plus 3, that is equal to 4. So 2x is equal to 4 and x is equal to 4 over 2, that is equal to 2. So we have now x is equal to 2, which belongs to this interval, that is 1 to 2. So x is equal to 2 is a solution of this equation, and we can also verify it by taking x is equal to 2 in the left hand side. So in the left hand side we have mod of x minus 1. So we have 2 minus 1. Then we have mod of x minus 2. So we have 2 minus 2, and 2 minus 1 is 1, and here we have 0. Mod of 1 is 1, mod of 0 is 0. So we have 1, that is equal to the right hand side, which is equal to 1. So this verifies that x is equal to 2 is a solution of this equation. Now let us consider the third interval. So now in the third interval we have x greater than 2, and here we have infinity, or we can write simply x is greater than 2, or we have x belonging to the interval 2 to infinity. So now let us again define mod of x minus 1 and mod of x minus 2 in this interval. So here x is greater than 2, and here we have x greater than 1 or equal to 1, then mod of x minus 1 is positive x minus 1. So here we have positive x minus 1, that is simply x minus 1. And here we have mod of x minus 2 is positive x minus 2 when x is greater than or equal to 2. And here we have x greater than 2. So here we have mod of x minus 2 as positive x minus 2, that is x minus 2. So now replacing mod of x minus 1 by x minus 1 and mod of x minus 2 by x minus 2 in this equation, we have x minus 1 minus x minus 2 is equal to 1. So now we can write x minus 1, then we have minus x plus 2 is equal to 1. So now here x and x get cancelled and we have 2 minus 1. So we have minus 1 plus 2. Here we have 1. 2 minus 1 is equal to 1. That is equal to 1. So here when we take x greater than 2, then we have 1 is equal to 1, which is a true statement, right? So for every value of x which is greater than 2, we have the inequality, the equality, that is 1 is equal to 1. So for all x greater than 2, we have 1 is equal to 1. So this implies that all values of x which are greater than 2 satisfies this equation. And when we have discussed this interval, we have seen that x is equal to 2 is also a solution of this equation. And for x greater than 2, we have 1 is equal to 1, which is a true statement, right? So this implies that this interval, all the values of x which belongs to this interval, that is 2 to infinity. Here 2 is included, or we can write x is greater than or equal to 2 and less than infinity. So here the solution of this equation can be described as this interval. So the solution of this equation is given by this interval where 2 is also included. And we can see that when we take this entire interval from starting from 2, and here we have infinity, then all the values of x belonging to this interval satisfies this equation. So the solution of this equation is given by this interval, that is from 2 to infinity. So here 2 is also included. So this interval represents or gives the solution of this equation. So now let us take some points in this interval, that is 2 to infinity, and let us verify that whether these points or these values of x are a solution of this equation or not, right? So let us take one point, say x is equal to say 100, right? And this number 100, it belongs to this interval, that is 2 to infinity. So let us substitute x is equal to 100 in this equation. So the left hand side is given by mod of 100 minus 1, then we have mod of 100 minus 2. So here we have mod of 99, and here we have mod of 98. So we have mod of 99 is simply 99. Here we have simply 98, that is the difference is equal to 1, which is equal to the right hand side, that is equal to 1. So x is equal to 100 is a solution of this equation, right? So let us take one more point. So let us take x is equal to say 250, and 250 belongs to this interval that is 2 to infinity. So let us substitute x is equal to 250 in the left hand side. So we have here mod of 250 minus 1, then we have mod of 250 minus 2. So here we have 249, and here we have 248, and a mod of 249 is simply 249, mod of 248 is 248, and the difference is equal to 1, which is equal to the right hand side. And this verifies that x is equal to 250 is also a solution of this equation, right? So from here we have seen that all the values of x which belongs to this interval satisfies this equation, and this implies that this equation has infinitely many solutions. That is, there are infinite real numbers which belongs to this interval are a solution of this equation.